Okay, good day, class. All right, so today we are going to do a small part of this chapter. So before this 5.1, we have learned about the four types of conics. Okay, circle, ellipse, parabola, and hyperbola. We have learned their the equation in standard form, general form, all right, and how to find the center, foci, vertices, and so on, right? And how to sketch all these conics. All right, so today we are going to see another part of this, another part of the conics. Means that another way we represent a conics. Before this, we learned the equation of the conics in standard form and general form. All right, now we are going to see how we can represent a conics by using a parametric equations. All right, so what is parametric equations? Okay, number one, if the coordinates of a moving point P with coordinate xy are such that x and y are the functions of another variable t. Means this x and y, because x and y they varies, right? P moving ma, so x and y keep changing. So let's say they change, follow a function. Okay, in another variable, let's say t. Normally we use t. All right, it can be others, small letter. So we say that x and y are defined parametrically or in terms of a parameter t, right? Where t should be any real number. Actually, you learn parametric in SPM also, just a little bit lah. Especially in chapter of differentiation. All right. Okay, number two. So we will write that. So because x is a function in terms of t and y also another function in terms of t. All right. So we can write as x equals ft and y equals gt. So these two are known as the parametric equations of locus of P. All right. This is the parametric equation where we'll write x and y in another variable. Okay, number three, any point on the locus is said to have coordinate ft, gt, and we know this as parametric coordinates. This is one example. Let's say x equals to 2t and y equals to 3t plus 1. So these two are the parametric equations. Okay, means when point P move, okay, the coordinate x and y change, follow these functions. All right, and from these parametric equations, how we can get back the Cartesian equations? The Cartesian equation is just like what we have learned in 5.1, the general form, the standard form. All right, so to convert an equation in parametric form into Cartesian form, very simple. For x and y, you choose either one and make t as a subject. Normally we use x lah. You can use y also, no problem. Okay, so I choose x, the parametric equation of x. So I make t as subject. So 2, we shift it to the left hand side. Therefore, t is equals x over 2, right? Then sub this t into your y. Okay, then you see no more t. Then this is a Cartesian equation. Okay, so this is how you, when you are given a parametric equation, this is how you express it in Cartesian form. All right, of course, this is only one of the very common method. We have other methods also. We are going to see, okay, in other parts. Okay, number 4. So to find the equation of the locus of a moving point with parametric equation, with parametric coordinates, ft and gt, then very simple, we follow this step. First, we write down its parametric equation. We write it in parametric form. Okay, the coordinate we express in parametric equation form. Then the equation of the locus of this moving point can be obtained by getting rid of parameter t. Means we make t disappear, something like this. So we will get the Cartesian equation. All right. Okay, so this is very general part. That some equation given you in parametric form and we convert it into Cartesian form. Not yet go to the conics yet. All right. So we are going to see example 5.2. So you see there are quite many questions here. All right. So this is general for any locus that we express in parametric form. Okay, we haven't go to the conics yet. We learn something general first related to this parametric equation. All right. Okay, so let's look at example 5.2. Okay, So you see the question say, all right, a point P with parametric equation, you see they're given you in 2t. So x equals 2t and y equals 0 lah. With t as the parameter, so it's a variable point. Variable point means P is moving lah. All right, and Q is a point with coordinate 6, 2. So Q is a fixed point, 6, 2. So a straight line perpendicular to PQ at P meets the y-axis at R. So show that the gradient of PR is this one and is t minus 3, and find the coordinates of M. What is M? Which is the midpoint of PR. Hence, find the locus of M as t varies. Okay, so this is the question. So first, always we sketch a graph. All right? We always sketch the graph so that it's easier for you to continue. Okay, let's see. The question says P is moving, all right, with x equals 2t and y 0. This one's simpler because y is always 0. Y 0 means it's on x-axis, right? It's on x-axis. So P moving along x-axis because coordinate y always 0. Then Q is a fixed point with 6, 2. So Q is here, fixed, 6, 2. All right, it's fixed. So a straight line perpendicular to PQ. So I connect PQ. So this is line PQ. So there's another line which is perpendicular to PQ at P. So at P, perpendicular to PQ. So this is a line. This is a line perpendicular to PQ at P. All right, and this line meets the y-axis at R. So the y-intercept is here, R. All right, so from here we are sure that because this is y-intercept, so the x-coordinate must be 0, right? And we don't know what is the y. Later we are going to find this one. All right. So show that the gradient of PR is t minus 3. PR. So because it is perpendicular, so we have to find gradient for PQ first. All right. So use the formula for gradient. So gradient for PQ is, okay, y minus y over x minus x. Like this. Right? So 2 can simplify here. Therefore, you get negative 1 over t minus 3. This is PQ. All right? Because PR is perpendicular to PQ. Therefore, PR, this one negative, this one positive. This is 1 over t minus 3. So this is t minus 3. Okay? This is how we show it. Okay? The gradient for PR is t minus 3. Okay, next, find the coordinates of M, which is the midpoint of PR. This is PR. M is the midpoint. All right. So remember one thing. Remember one thing. P is moving on. This is only one example if P is here. All right. So imagine if P moves here, then your PQ become like this already. Your PQ become like this. Then perpendicular. So your R is here already, you see. Can. So P is moving along here. So when P move, R also will move lah. When P is here, R is here. When P move here, R move here. See that? So M is a midpoint of PR. So when P is here, R is here, M is here. So when P is here, R is here, M moves somewhere else. See that? So P, M, and R, they're various. They change. Okay? When P change, R will change, M will change also. Therefore, next they want us to find the coordinate of M. All right. So midpoint of PR. So coordinate P I have, but coordinate R we don't have. Remember, we don't have the coordinate of R. So we have to find the coordinate of R. All right. So since we have the gradient for PR, and we have one point P. So from this one, we can form the equation for PR. All right, so y minus y equals mx minus x. Okay, then we expand. So y minus 0 is still y lah. So this is gradient m. So gradient m times x, gradient m times this. All right, so this is in gradient form. Y equals mx plus c. So y equals mx plus c. So this is our c means y-intercept lah. C is the y-intercept. Therefore, point R will be 0 and y-intercept. So after we get the coordinate for point R, so the next will be find the medium M, or the midpoint of PR. Or use the formula for midpoint, remember? X plus X over 2. Y plus Y over 2. Alright, so after we simplify, you see, 2 and 2 simplify. This 2 and 2 also simplify. So this is the coordinate for point M. So this is parametric coordinates. So remember this is in the third variable t. So we call this parametric coordinates. Can see. I can see. Alright. Okay, hold on. Okay, sorry. Okay, now can see. Okay. The midpoint M. So x plus x over 2, y plus y over 2. So after simplify, you get the parametric coordinates for point M. Alright? So we write it in parametric equation form. This is parametric coordinates. So we write it in parametric equation form. So x equals t and y equals this one. Alright? Then remember, we sub it into this one. So since x equals t, right? So we sub 1 into 2. So y equals negative t. T is x. So t is x. Alright? This is the equation for locus of M. Alright? This is a simple one. Actually, without the diagram, you really can't see. But with the diagram, then it's actually quite easy, right? Okay, so you see the question would like to ask you to find the locus of a moving point. They would like to ask you to find the locus of a moving point. So in that case, actually, we can simplify it like this. Okay, we can simplify it like this. If want to find the locus of a point, so find its parametric coordinates first. So like this. Okay, then find the relation between x and y. From the parametric coordinates, we write it in parametric equation form. Then we try to find the relation between x and y. We eliminate the t. This is generally lah. Generally, this is a step. Okay. So this is question 1. All right. Second question. Okay. All right. Oh, here some. Okay, never mind. Later I push up a bit. Okay, so question 2 is quite long. So question 2 is quite long. All right, so you try to follow. Okay, question 2 say a variable point P lies on the line x equals -4. And O is the origin. Okay, so this is the axis. All right, line x equals -4 is this one. Now I label one by one. This is the line x equals -4. So point P lies on this line. So point P move along this line. Alright, so the coordinate for point P very sure because it's a move along the line x equals -4. So the x coordinate is always -4 and y keep on changing at different position, y will be different. Okay, then O is the origin. A straight line which is parallel to the x-axis. So there is a straight line parallel to the x-axis means it's a horizontal line. Alright, passes through P. So let's say here, let's say P is here. So there is a horizontal line pass through P. This is the line. Alright, and this line meets the straight line which passes through the origin O and perpendicular to OP at Q. So means that now we are going to talk about another line. Another line passes through origin and perpendicular to OP. So just now we say P is here, right? Let's say P is here. So this is line OP. Alright, so there is another line pass through the origin and perpendicular to OP. See, this is the second line. Perpendicular. Alright? Can I? So this line meets this line at Q. This is the meaning of the question. Okay? So, and this is diagram. Alright? Show that the locus of Q is y squared equals 4x. What is this? What coordinate is it? Yes. parabola, right? So show that the locus of Q is this one. Because we know that when P moves, let's say P moves here lah. Let's say P move here. Okay? Then the horizontal line will be here. Okay? This line fixed also. No, sorry. So OP will be here already, you see? I hope you see with different color. So OP is here already. Let's say this is P also. Alright? OP is here. This is a horizontal line, this one. And OP is here. So there is another line that perpendicular to OP and pass through origin, right? Like this. Perpendicular to OP and pass through origin. Alright? So this line meets the horizontal line at Q. Alright, so you see the blue one and the black one is the first set. Let's say P is here, this is the first set, so the Q will be here. Red color one is second set. Let's say P move right? P is moving so let's say P move here. So OP here already. So the line pass through origin and perpendicular to OP is this line. So this line meet the horizontal line at Q. So you see now Q here already. Okay, so from here very clear. When P moves, Q also moves. So now they want you to prove that the locus for Q is a parabola. No matter where Q move, it will form a parabola. This is what the question wants us to show. So it's a bit long. Sorry. Question 2 is not long. The long one is question 3. Okay, question 2 is quite short. Alright. Okay, so to find coordinate, remember, to find the locus of point Q, we find the coordinate first, right? So to find these coordinates, it's an intersection of these two lines. So we find the equation of these two lines. Okay? So first, we find the gradient for OP first. If P is here, so the gradient for OP is, so y minus y, x minus x. So this one. So this is the gradient of OP. Alright? Then the gradient of OQ, perpendicular right? Perpendicular. So this one negative, this one positive. This one y over 4, this one 4 over y, because they are perpendicular. Alright? So you get the gradient for OQ already. So I have the gradient. I don't have to find the intersection point because I can find the equation. I straight away can find the equation already. I don't have to find coordinate for Q. If you want to find coordinate of Q also can, but a bit longer. Alright? This one shorter. So I straight away find the equation of Q. So to find equation of Q, I need the gradient, right? So after gradient, because given you OQ passes through origin, therefore the equation of OQ will be y minus y, m, x minus x. So this one, y can shift it here. So you get y squared equals 4x. This is another way that you can find the locus of a moving point. Alright, what we have shown just now, the question 1, we find the coordinate first. We find the coordinate of the moving point, then we form the parametric equation. From there, we eliminate the parameter t. Then we get the locus. This one no need. Alright, this one no need. This one straight away, if we do like this, we can get the locus already. Alright, so to find the locus of a moving point, actually quite many methods. It depends what information given to you and how you solve it. So you really need a lot of examples so that you can do it. Alright, okay, so next will be question 3. The long one is actually question 3. Question 3 is a long one. Alright, so let's see what is asking in question 3. A straight line y equals m x minus 2. So this is a straight line. Passes through a fixed point 2, 0. Alright, meets the line x equals 1 and y equals k at A and B respectively. Alright, so there are two fixed given to you, point 2, 0. So let's say 2, 0 is here. Alright, and another thing is x equals 1. The line x equals 1, so this one. So these two fixed. This point and this line fixed, never move. Okay? So a line y equals m, this is a line, but the gradient can change, you see? Gradient will change. Alright? So this line passes through this fixed point 2, 0. So the blue one. I draw the blue one. Y equals m, x minus 2. This is only one of it. So this line can be like this, right? True or not? It can be like this one, as long as pass through this point. Depends on the M. If M is smaller, then more horizontal. If N is bigger, then the line will be more vertical. More vertical, right? So this is a moving line. Okay, this line can move. But one thing is, it's always pass through here. Okay, so this one, because too many, so I only show one example lah. How I cannot show too many things like this, so you will confuse. Okay, I just show one. So this line passes through this fixed point, meets the line x equals 1 at A. Okay, so A is here. Can. And meet another line y equals k at B. So I don't know what is k. So let's say, because y equals k is a horizontal line, so I just draw any. So means that this y equals k also can move. Or can be here, can be here, can be here. Okay, so means that this blue line will move like this. But no matter how it move, it will always pass through this one. But else y equals k move up and down. Okay, these two line moving. Okay, so this blue line intersect this line y equals k at B. So A is here, B is here. Okay, so this blue line intersect y equals 1 at A, intersect y equals k at B. Okay, until here. All right. If O is the origin and P is the point 1, 0. So P now is a fixed point 1, 0. So I mark here. All right. P is here 1, 0. Find the equation of line OA and PB. They want the equation for OA and PB. See, they want the equation of these two lines. Then after that, if M varies, as I say, M can change, right? If M varies, find the equation of the locus of the point of intersection between OA and PB. OA, this one. PB, this one. So this is the intersection point M. Excuse me. All right. So this one also change, right? As I say, when M change, when y equals k change, right? So so OA will change, PB will change. When OA and PB change, this intersection point M also change. So M is also a moving point. All right, so they want you to find the locus of this point. They want you to find the equation of the locus of the point of intersection between OA and PB. So they never, I give it a name lah, point M lah, easier ma. This question never give, but I give it, or I name it as M. So with the diagram, when let's say in exam, the marker know what is M because you show it in your diagram already. So the diagram is very important actually. Okay. So now our purpose is to find this, and to find the equation of OA and PB actually is a guideline. So to direct you how to find M. All right. Okay. So let's see. All right. This one cannot see so I move up a bit lah. Okay. I move out a bit. All right, so now I can see already. Okay, so let's, how to find OA. Can see? OA is here, right? So to find OA, because A is given, A is lies on here, and this is the line x equals 1. So definitely the x coordinate is 1 lah, right? But when it's changing, then y is changing lah. So the coordinate for A is 1y, right? So, and this point A lies on this line, right? So I can sub the coordinate of point A into this equation. Okay? So y equals, y is y ma. Y is y lo, so still y lo. And x is 1. Alright? So from here, I get that y is actually equals to negative m. This y change follow the gradient of this line. Okay? So the relation between y, this y. Okay? So y is equals to negative m. Therefore, point A is 1, negative m. Alright, so you remember, you are given in the question m variable, k variable. So your answer should be in, can be in m or k, or either one. Alright. Okay, then O is the origin, right? OA ma. O is the origin. So I have point A, I have point O. So I can find the gradient of OA. Y minus y over x minus x. So I get that the gradient of OA is negative m. So from here you get one concept, right? Never mind. It's okay. Okay. So it's negative m. The gradient for OA is negative m. So you have a point, you have gradient. So we can find the equation for OA lah. I take this as a point lah. So y minus 0 equals gradient is negative m, x minus 0. So this OA, line OA, the equation is y equals negative m x. Okay, so this is the equation for OA. I name it as equation 1 first. Okay, then PB. Alright, how to find the line PB? Okay, so B, the coordinate very clear because B lies on the line y equals k. So the y coordinate must be k. X we don't know, right? So let's say the coordinate for B is xk. So, and again, this B lies on this equation also, right? So I can sub the coordinate for B into this equation. Sub in. So y is k. X is x. Alright, so from here, you see I get x. Alright, m shift here, so k over m. Alright, minus 2 shift here, plus 2. So x equals k over m plus 2. And I actually combine it, become one single fraction. Because we want to know what is x ma. What is the coordinate for x ma. Alright, therefore, point B is, coordinate x is k plus 2m over m. Alright, and coordinate y is k lah. Alright, so I get point B already. And point P is given ma. Okay, so can get the gradient for PB already lah. Y minus y over x minus x. X minus x. Y minus y, x minus x. This is a little bit complicated here lah. So let's see. I move it to this side, okay? Continue here. Okay, I lipat first. Okay, continue. Okay. Can see. Okay, can see. All right. Okay, later I move out a bit. Okay. So just now the gradient for PB is this one. So now we simplified the denominator part. I combine it as one fraction. So 1 is m over m lah. M over m, right? So k plus 2m minus 1m. 2m minus 1m. So k plus m only lah. The denominator is m lah. I do this one. I combine and do this. Alright? Then divide a fraction. You multiply and reverse the fraction, right? So m come up here. So this is the gradient for line PB. Okay, and again, we have point P ma. Point P is 1, 0, right? So you have gradient, you have 1 point, so we can form the equation for PB. So y minus 0, this one, m, gradient just now we have calculate here, this one, x minus x. Okay, then y minus 0 is y lah. So gradient multiply x and gradient multiply 1. Alright, so this is the equation for line PB lah. Okay, so this is the equation for line PB. So I name it as 2. Remember, this is equation for OA. This one. This is the equation for PB. This one. Alright, and they intersect at M, right? OA, PB, intersect at point M. So intersect means we find we solve simultaneous equation to find point M, right? Yes. So we sub 1 into 2. Sub equation 1 into equation 2. Because we want to find the intersection point M. Okay? So y equals negative mx. So y equals negative mx. This one remain the same. I just copy. Alright, we want to find x, right? We want to find we eliminate the y. So means the next step is we want to find the x coordinate. So I have to rearrange this whole thing to get x. So I have x here, I have x here. So I have to group all the terms in x together. So I shift minus mx shift here become plus mx. So I factorize out x. So it's km over k plus m, the m from here. Alright, so this one minus km over k plus m, I shift it here, become positive. Okay, so next step is, I want to combine this one as one fraction. So this one will be m over k plus m lah. Over k plus m. So after simplify, you get back your m, right? So after that, you see this is km, this is also km. Right? So 2km, right? 2km. 2km plus m, right? M square, sorry. 2km plus m square. Okay? Therefore, x is, so this one, shift it to this side. You reverse the fraction. This one copy. Imagine this one, you shift it here. So this fraction, you reverse, right? See or not? Reverse. Okay? 2km plus m square is from here lah. Can or not? Now you find your x coordinate. Okay, so very simple. You see that k plus m simplified. Alright, and m and m here, m, 1m and 1m can be simplified. Right, so the numerator left, k only. The denominator left, 2k plus m. Okay, can see, okay, I move out a bit. Alright, so x shift here after you rotate. So after simplify, you see that your x coordinate is k over 2k plus m. Alright, then sub your x coordinate into equation 1. Into here, easier, right? You don't sub into here lah. This one's so complicated. Okay, we sub this one in here. Easier to find the y coordinate. So y equals negative mx. Okay, it's just like that. Therefore, the coordinate for point M will be x equals k over 2k plus m from here. And y equals this one, negative km over 2k plus m. Okay, right? Alright. So, again, so this is the coordinate. So remember, we write it in parametric form. We write it again in parametric form. So x equals this thing. Alright. K, remember, k is given. It's a horizontal line, this one. Okay, so we will remain k. Now we try to eliminate m. Remember the question said m various. Let's see in the question. If m various. If m various means m is the parameter. Okay, m is the parameter, not k. Alright, so m is the parameter. Okay, not k. So we eliminate m. Now what we are going to do is we eliminate m. Alright, so from the x coordinate, this parametric equation, x equals k over 2k plus m, I'm going to rearrange this thing so that I will get k. I will get k. I will get m in terms of k. Alright, so first step, I shift this one to the left hand side, multiply with x, so 2kx, mx. Alright, so m is here. So I shift this one to this side, so minus 2kx. Alright, so this one left mx. So m is x shift here. So m is equals to k minus 2kx over x. Then I sub this one into the y coordinate. Okay, the y coordinate means this one. Okay, so y equals negative m. M. So this is m. Okay, this one. Follow this one. Just the m sub like this because you already get m here. Alright, now we are going to simplify this one. So you see that now the equation, now you see that now the equation is in, now the equation is in k and x only, no more m. I got one more m here. Okay, this is negative m, this one, one more m here. So I sub in difference. Then the next step, I sub in this m. M equals this thing, sub in here. This is another m here. Alright, so I simplified this denominator part. I combine them as one fraction. So this one also times x, 2kx plus k minus 2kx. So the denominator will become, can see now? Okay. So the denominator will become x. Alright, so you see 2kx minus 2kx no more. Left k over x. This one just copy, KOX. All right? Okay? Okay, then the next, I'm not yet finished. That's why I said this is quite long. Okay, so the next step is here. Almost finished. Okay, so the next step is here. See? You see, okay. All right. So next step here. So this is over kx, so reverse become xk. So k and k simplify. Right? X and x simplify. Right? So left this one only. So left minus k plus 2kx. So we write in general form lah. Okay? 2kx, y shift here, minus y, minus k. So I write it in general form. General form. X, y followed by c, right? So this is the locus of M. Alright? So you see that actually the locus of M, I put it here. Remember this M? So no matter where this line move, where this one move, okay, M actually move in a straight line. The locus for M is a straight line. Okay? So I try to arrange the whole solution in one page. Okay? Okay. And here. Okay, move it a bit inside. And move it a bit inside. Okay. Okay. And here. Okay, I hope you can see. Okay. I'll start from the diagram. Find line OA, find line BP, find the equation for BP. Okay, solve simultaneous equation to find point M. Then from the parametric equation, you will eliminate the parameter M. How we know the parameter is M? Because the question say M various, right? Then you form the equation of locus M. Okay? So I hope you can see everything in one page, right? The whole solution. Okay. All right. So next, we are going to see some STPM question. Okay. So STPM 2009, I want you to do as homework because it's quite simple. I want you to do as homework. All right. Please do it. I will explain to you. Then you continue the working. All right. So you see question 4 say, the parameter equation of a straight line L. So L is a straight line. Let's say this is like L. This is L. Just a straight line. Alright. Are given by x equals 4t minus 2 and y equals 3 minus 3t. So this is the straight line. So you see, one straight line also, we can represent this straight line by using parametric equation. Not only curve or conics. Alright. Then show that point A lies on the line L. Let's say A is here. What is this? Hold on. Find the coordinates. Find the Cartesian equation of line L. Given that L cuts the x-axis and y-axis at P and Q respectively, find the ratio PA. Hold on. What is this? Show that. Okay. Find the Cartesian equation of line L. Given that L cuts PQ, find the... okay. I make a mistake. Sorry, I make a mistake. So this is a line L. Okay, this is line L. Okay, so this is line L. Given the parametric equation, show that A lies on L. So A should be here. Sorry, A should be here. Not this thing. Okay, not this thing. Okay, I make mistake. Okay, show that point A lies on L. So how to show it? Very simple. You sub x equals 1 into this to find t. And you sub this y into here. Sub x in this to find t. And sub y in here to find t. and you should get both T the same, must be the same. Both T give you the same answer. If you can show this, then yes, you can make conclusion A lies on L. All right, simple, right? Then find the Cartesian equation of line L. Just like I have explained, right? Question 1, remember? Question 1 and also the example here. The example at page, this one. Just use this method, all right? To find the Cartesian equation of line L. Because 2 marks only, ma. Okay, then the question say, given that L cuts the X and Y axis at P and Q. So P is here, because cut the X and Y axis, ma. P is here, Q is here. All right, find the ratio for PA, AQ. Use the, not this one, so this one wrong. Okay, this one wrong. So means use the formula for ratio lah. Remember the beginning part of the notes of this chapter 5 notes. The formula for ratio, the lambda mu lambda x2 plus mu x1, that one over lambda plus mu. Use that formula. Okay, so to use that formula, you want to the question want you to find the ratio. This is actually the question for this is actually the question like form 5. All right, so okay, never mind. I tell you, let's say PA is lambda or AQ is mu. All right, the different thing is, before this you are given the coordinate for this one and this one. All right, and they give you the lambda and mu. Okay, so the formula is for you to find coordinate for A, but now a little bit change. Okay, so the coordinate for A is, okay, let's say this one is x1 y1, this is x2 y2. Remember, so lambda multiply x1 plus mu multiply x2, lambda multiply x2, lambda multiply x2, mu multiply x1 over lambda plus mu. Remember, this is coordinate x, so y also the same. Use this formula, but now A is given, A is given 1, 4 over 3, right? So you just need to compare one of the x or y. Either you want to compare x or you want to compare y, but it seems like compare x easier because it's 1. Because x1, x2 you have to calculate lah. You have to find the coordinate for P and Q. You have the equation already, right? So no problem for you to find coordinate for P and Q. You have your x1, x2. Okay? Then you sub in your x1, x2 and the x is equals 1. All right? Then you arrange it. You sub in your lambda x2 plus mu x1, lambda plus mu equals 1. You compare the x coordinate. Then you rearrange this one. You rearrange this one until you get lambda over mu. Yes. You rearrange this one. Rearrange to get lambda over mu at the left hand side. Others move to the right hand side. It will be a number. Okay, so once you get this number, you can make this conclusion. You express your answer in this way. Okay, so I want you to try it. Never mind, you do it as quiz. Alright, I give you until tomorrow morning. Tomorrow is Thursday, right? Yeah. Or tonight you complete it. It's not difficult. Please complete tonight this question and you send it to the Google Drive. Alright, you send it to the Google Drive number 2 for chapter 5. Google Drive 2 for chapter 5. Okay, you send it tonight. So I will mark tomorrow and then I like the last quiz or I will forward you your solution. Okay, do it as a quiz Okay, then only I know whether you do or not. Okay, then next question 5. I will going to discuss all the past questions. Okay, I want to explore you to different question. Okay, one more question 5. 6 we forget about it because 6 involve trigo. All right, the differentiation of trigonometry, which you haven't learned in form 5. You're going to learn it in SEM 2. All right, differentiation of trigonometry will be in SEM 2, so I don't want to disturb you for this. So I'm going to discuss 5 only. All right, this one we forget it, or maybe in future in SEM 2. Maybe this question will appear again in SEM 2. Then only we discuss. Okay. All right. So question 5 is also not difficult. Right? It's STPM 2004. All right. STPM 2004. Can you see? All right. Can see the whole thing. Okay. So it's given that a curve is defined by parametric equation. So you are given parametric equation. X equals 1 minus 2t, y equals negative 2 plus 2 over t. Alright, find the equation of the normal to the curve at point A. Alright, if you this one no need to sketch lah. But if you really want, it's just any curve, any curve. This is the parametric equation of the curve. Okay, so there is a point lies on the curve, which is point A. Let's say point A is here with coordinates 3, negative 4. Alright? They want you to find the equation of the normal. So at this point, this is a tangent. Right? This is a tangent. So normal will be this one. Remember normal? It's a line perpendicular to the tangent. So the question wants you to find the equation of this line. So to find equation of a straight line, you need a point. So point you have already, and you need the gradient, right? Yes. To find the gradient of normal, in Form 5 you have learned, you need to find the gradient of the tangent lah. Alright? Because they are perpendicular ma. So first step, you have to find the gradient of the tangent. Still remember to find the gradient of the tangent? I hope you still remember. Yes, which is differentiation, right? Gradient of the tangent is actually same as dy dx. Alright, so how to find dy dx? Like this. Okay, so you are given parametric equation x equals 1 minus t. Okay, I find the Cartesian equation first. There are two ways. But I teach you this one first. This one will be easier lah. Okay. So I find the Cartesian equation first. You are given parametric. I find the Cartesian first. So I use this one and use t as subject. So 2 minus 2t shift here, x shift here. So t equals 1 minus x over 2. Sub this one into your y. So it's negative 2 plus 2 over t. Alright, so over 2 over t means 2 over... Oh, 4 Alright. Yeah, it become 2 over 1 minus x or 4. Okay, sorry, 4. Alright, so this is y. This is a Cartesian equation. So the equation of this curve is x equals negative 2 plus 4 over 1 minus x. Alright? So I write it in a proper way. I just put this one at the back. Okay? So we differentiate this one. Differentiate this one. Okay? So differentiate this one, not difficult, right? 4 is still 4. Right? This is 1 minus x to the power of negative 1, right? This one shift here, negative 1. So to differentiate, index in front. Okay? Index in front. Copy. Index minus 1. So square lo. Minus 1 is negative 2 ma. Move back to the denominator square lo. And multiply with differentiate this one, remember? So differentiate negative x is negative. Negative 1. So just now index it in front, negative 1. To differentiate this one, okay, I do it. To differentiate this term. So index in front, copy, index minus 1, and multiply, negative 1. Differentiate inside. I think I discussed this one in chapter 1, right? So negative, negative, positive. Positive. Okay? So it's like this. So differentiate constant 0, right? Differentiate constant 0. So this is your dy dx. Alright? So at point A, where x equals 3. So the dy dx means the gradient of the tangent at point. So x equals 3, I sub in 3 here. Okay, so careless mistake. Okay, sub in 3 here. So means that minus 4 or 1 no? The gradient is 1. Sorry, the gradient is 1. Okay, 1 minus 3 is negative 2. Negative 2 square is positive 4. So 4 over 4 is 1. Alright, so the gradient of the tangent, this one. The gradient of the tangent is 1. So if the tangent of the gradient is 1, what is the gradient of the normal? Perpendicular, right? So this one positive, this one negative lah. So the gradient of the normal is negative 1. Therefore, at this point, x3, y negative 4, sub into the formula, y minus y over, m, m, x minus x. All right, therefore your answer is, okay, I rewrite again. Can see okay, I rewrite again. So the answer is y equals, so this one negative x, this one positive 3, negative 1 times negative 3, positive 3. This one plus 4, shift here minus 4, right? Plus 4, shift here minus 4. So 3 minus 4, negative 1. Okay, so this is the equation of the normal. Okay? All right, can see Okay. So this is question 5, STPM 2004. Question 6, you forget about it. Because it's involved actually something like differentiation also, but you need to differentiate the trigger. This one, never mind, we don't learn this. Okay, so after you have finished the video, please do question 4 as a quiz. All right, and upload it into the Google Drive tonight. All right, so if I can make it tomorrow another video, then I will forward to you. Okay, all right, thank you, class.